Hello everybody. I'm going to do a quick video over acceleration just to give a little more structure to the notes we took today and give you a centralized place where you can kind of access all this info. So acceleration, let's talk about it. What is acceleration? Well, acceleration is simply the rate of change of velocity. The rate of change of velocity. Now, velocity is a vector, all right? So what that means for us, since velocity is a vector has magnitude and acceleration. Not acceleration, magnitude and direction. So since velocity is a vector, and a vector can have magnitude and direction, that means a change of velocity can either be a change in magnitude or a change in direction. All right, so a change in magnitude would just be a change of speed. Change in magnitude is simply a change of speed. And a change of direction is exactly what it sounds like. So a scenario where you would be changing direction but not changing speed. So let's imagine that you are driving along in this direction and then you hit a turn. You hit a turn and you turn your car. All right? So when you turn in your car, let's say that you stay at the same velocity, say 60 miles per hour. So at every point along this turn, you're going 60 miles per hour. So your speed is constant, but your direction changes. And since the direction of your velocity changes, you have an acceleration. So let's look at this in terms of motion mapping. So if I have an object that is speeding up, our motion map, the dots are going to get progressively further and further apart. All right. Now, as those dots get further and further apart, the reason for that is because we're experiencing an acceleration. That acceleration is the same magnitude the entire time, and it's pointed in the direction of the change of velocity. So here, our change of velocity was positive because it's changing in that direction. Therefore, our acceleration is positive because our velocity is increasing. An increase of velocity is due to the acceleration going in the same direction. If we have an object that's slowing down, we're going to have a scenario where our acceleration is opposite the direction of our velocity. So our dots are going to get progressively closer. So we're still moving to the right. We're still moving in the positive direction. But now we have an acceleration in the opposite direction because we are slowing down. So we have a negative acceleration because we have a negative change of velocity. So our velocity is to the right, our acceleration is to the left, therefore we slow down. So one of the main ways that we're going to look at acceleration is we're going to look at acceleration from a velocity versus time graph. So on a velocity versus time graph, when we did constant velocity, we were used to seeing graphs that were flat like this. And this told us that at any moment of time, I'm experiencing the same velocity because I was moving at a constant rate. Now what we're going to be looking at are situations where our velocity is changing at a constant rate. So in this case, we have a changing velocity due to acceleration. Now, where this gets tough is recognizing when you're speeding up and slowing down. So let's say that I have some different graphs that represent me speeding up. Okay? When we speed up, the magnitude of the velocity increases. Remember, speed is the magnitude of velocity, so we are looking for the magnitude to increase. That can be either increasing in the positive direction or in the negative direction. So we can have a graph that looks like this for velocity and time, or it could be speeding up and look like this. Both of these scenarios, my velocity is getting further and further away from the x-axis. All right? It's getting further away in the positive direction there, and it's getting further away in the negative direction here. So in both situations, I'm speeding up. Now, if I was slowing down, you can imagine that my magnitude is decreasing. So we look at some scenarios again. I'm going to have a velocity that starts off high and goes to 0. Same thing here. Here, I've got a velocity that starts in the negative and goes to 0. The reason for this is because, again, instead of getting further away from the x-axis, we're getting closer to the x-axis. As we get closer, the magnitude of that velocity goes down, and therefore we end up slowing down. But what's hard about this is that the slope can be in different directions. So let's kind of analyze these a little bit closer. Let's look at this one right here. So in this case, I have a positive velocity. And if you look at the slope of my velocity here, the slope of my velocity is also positive. So since the slope is positive, I have a positive acceleration. And like we talked about before, if I'm speeding up, I'm going to be looking for a positive velocity and a positive acceleration. And that's what I have in this case. A positive velocity, or a positive change of velocity would be a better way of thinking about this, and a positive acceleration. Now if we go down to the second graph here. Here, I have a positive change of velocity, and you may be, I have a negative change of velocity here because I'm going down, so a negative change of velocity. And then if you look at the slope of that line is negative because I'm going down. So since the slope is negative, that means I have a negative acceleration. And you notice here, again, even though they're both negative, they're in the same direction, therefore I'm speeding up. Now over here, in this case, I have a positive velocity because my velocity is above that line, that x-axis, but I have a negative slope. Positive velocity and a negative slope. That's going to give me a negative acceleration. Down here, it's a similar thing. Here, I've got a negative velocity. So I'm moving in the negative direction. But the slope of that line is positive. Therefore, I have a positive acceleration. So since in these cases my signs are different, I have a slowing down happening. In the case of these graphs over here, since my signs are the same, I have a speeding up situation happening. The reason I erased those change of velocity signs is because it's better to think about it simply as what direction am I moving. Here, I'm moving in the positive direction. Here, I'm moving in the negative direction. Therefore, I have a positive velocity and a negative velocity. The slope is my acceleration, and that's how I can figure out the rest of that. That's where I'm gonna stop for now. We'll keep exploring this in class, but hopefully this gives you a little bit of clarity as to what is happening here. Thanks for listening, guys.